Is this a good idea? You know, I mean, it's just that it's so simple but so powerful at the same time. You can just use it over and over and over again. Just like the first 2 minutes of the lesson, you can just do to do this. Okay, let's go. And basically, what it is, I wanted two numbers that add to be 7 root 2, but then I actually want to know what the product of those two numbers is. So, what are possible answers to that question? 0, 12, 20, 24. Are there others? 14. So that's just, is that just 5 answers? Yeah, there possibly will be only 5 answers, isn't it? 0, 1, 2, 3. Oh yeah, surely we don't go into negative numbers, but you could, of course. How'd you get 65? Oh, okay, 0.5 root 2 plus 6.5 root 2. Okay, so now we're going to get, and now we could actually draw a graph of those answers. Is there something about that's a pattern about that set of answers that we could actually draw in order to do that? And so far we have actually just been restricting it to the positive, in this case, irrationals, but to do that. Okay, what might be the missing numbers there? So -4, +3, and can you see that we're factorising quadratic trinomials now? That's what this is doing? And of course we could still get by without the number at the top and get a whole range of answers where we're saying these two numbers add to be -1. And so we get the kids the experience of doing this without having them to do it. Can you choose one of those, please? So I've got four examples. Choose one of them and do it. Each of them has got just a single answer. Just choose one and do it. Now, you might say, oh, this one's a trivial one. And it is a bit trivial if the kids are allowed to use their calculator. But what if you're doing it without your calculator? What do we know about what sort of numbers multiply so that the last digit's 1? And if those numbers, what sort of numbers of those set of numbers multiply the last digit 1 that they add to be 0? And so, okay, we can now start to narrow things down a bit. So it's going to end in a 3 and a 7. And so, well, okay, well, what's 53 times 47? Well, that's too big. So, well, what about something else? And so we can actually go through a relatively limited number, but it's actually studying some of those important things about number and principles of number. It's not just remembering the tables. So I think that's one. This one here, of course, is a half and a third. And we get to see, again, that power of the thing is that what fractions add to, what fractions multiply to is less than what they add to. We did this one already. Did anyone do this one? Okay, so it's the difference of two squares. And it's one of these really fundamental principles, but that actually illustrates the power of it in a way that you don't actually get when someone says, oh, here's the rule, just remember that. So you can, what I'm really trying to say is, and I was trying to give you this range of things. It's not just something that's for grade 3 teachers. This is something that could be for year 11 teachers and everywhere in between. Maybe even year 12 teachers, giving the kids just a 1 minute warm up at the start of your class.
When I did the 1411, I didn't start with what to do. I used divisibility rules to go through and say, okay, does 3 go into that? No, it doesn't. Does 4 go into that? No, it doesn't. And so I eliminated a whole lot of numbers and realised that it had to be 13 or 17 or whatever.
So divisibility rules, so we actually then raises a whole other topic we can introduce. Okay, here's something that looks like a simple question, but actually it starts to get to some of the power of mathematics and what, in a sense, what real mathematics is about is divisibility rules and how do we see patterns and the principles. And we're just trying to find a way to introduce this stuff to kids, and I think that's okay. Can I... So we're now going to start the day. By the way, I sort of want you sitting in your school groups as far as possible. Now, if people are not, if you like, here by themselves, please sit wherever you like. But for the people who are in the same school, if you could be sitting together. Can I tell you about my last week? Last week I was at Ulara, which is near Uluru. And I was visiting 3 secondary schools there that were for remote communities. And the communities are very remote, and they're actually, one of the communities was actually the rationale for the intervention in the Northern Territory, so they were very difficult places. And what happens in those schools is the kids sort of stroll into school, secondary schools, but there's only like one class, so that if you're teaching there, you're teaching every subject to these kids from year 7 to 10. So it's a bit of an interesting experience. And you're teaching the whole week as well too, what's more. So, but what happens there is that when you're teaching, you might be teaching a lesson, the kids just get up and go home if they don't like it. And so it's a really interesting experience because you think, wow, that changes the nature of learning quite a lot. Now, my view is that, well, the communities have got to get, you know, this is where the partnership comes in. The communities have got to get to the notion, well, the kids have got to stay at school. But on the other hand, the teachers have got to get to say, we've got to make school interesting enough that the kids want to be there. And so it's this sort of partnership challenge thing. And it's really sort of such an extreme form of the challenges you're experiencing that it was really quite interesting. But the other part of the last week that I had is I happened to be asked by a school, one of the elite schools of Victoria, one of the very, you know, like they pay $20,000 a year or something in fees, the parents. And you can't believe how boring the teaching is there. You cannot believe how bad the teachers are. And it's because the kids just sit there and whatever the teacher says they do, and all the kids have done is they've just learned to follow rules. The teachers haven't had to bother about making their stuff interesting or engaging the kids for years. They just tell the kids some rules and the kids practice them and they don't know anything and they can't persevere. So it's, if you're like the extreme other end, where the kids wouldn't raise a question if if there was a fire or something, and so you sort of say, you know, like that there. You know, the teachers sort of really needed to think, you know, they had the most wonderful kids you could possibly imagine who just sat there and sort of pretended to be working. It was just awful. In terms of... Yeah, it's sort of... Yeah, like I'm sure that people would say... Yeah. Oh, sorry, yeah, that's right. Oh, yeah, from a management perspective, they didn't have any management. You know, like the teachers would, you know, some kid would have his shirt hanging out and the teacher would pick a fight with the kid. You know, what are you having your shirt hanging out? Come on, you know, you sort of think, oh, you know, that what they'd be better to do is to try and engage them a bit. Now, you're in neither of those cases. You've got your own challenges. And maybe even the challenges at these 8 tables are all different from each other in a similar way. And that's what this program's about, is saying, okay, how do you address the challenges? This program is called Whole School Approaches to Numeracy and Mathematics Planning and Teaching. Now, the truth of the matter is that the Northern Metro region wants you to just do the middle line. I mean, seriously, they out of the program, they want you to have done the middle line. The numeracy and mathematics planning. You know, developing a plan. Now, my view is it's not worth doing it, and unless it's whole school approaches, you've got to get the whole school involved. And to me, it's also not worth doing it unless you think about the teaching as well. But just so that you know that that's what we're doing. Now, last time, when we were here, we talked about the rationale for whole school approaches. Why would you try and do it together? Why don't you just get the good maths teachers together and forget everyone else?